Hi, we're going to go ahead and move on to our next inference video. And so what we have is our inference with means, video number 2, our review. This one's going to be on 2 independent means, the intervals and tests. Okay, so 2 totally separate groups where we would have 2 means written. We'll talk about their conclusions and their assumptions. All right, so let's take a look at that. Now, we have talked about this. I kind of show you how to do this by hand. Okay, so again, here's our interval formula with our statistic. Now, when we are doing 2 means, we are looking at the difference between 2 means. So therefore, see, our statistic is this difference between those 2 samples that we get. Because remember that when we are doing an interval, we're estimating the population amounts from our sample results, okay? And we're getting that plausible range to estimate. Then we have our critical value, which is those t-distributions we talked about in the last video, y. And then this formula is on the formula chart of that standard deviation for the 2 samples, okay? The standard deviation for those 2 sample means. All right, but we pretty much don't do this by hand when we're doing our computing. So we do this pretty much in the calculator, okay? I've shown you this formula more or less for the identification, for multiple choice problems and such, or if it's written out there so you can identify things, but we did ours in the calculator. Reminder that this is a 2 sample t interval. And reminder that with means, you have 2 options on the input, either data, individual pieces of data, or the stats where the summary statistics are given to you, okay? You want to make sure you are keeping straight which type of item, which context item you're saying are the first information and you're putting in first, and which ones are the second. It's important that you're paying attention to the direction in which you are subtracting. The calculator does the ones minus the twos. So if you put the men in first and the women's values in second, then you would be doing the men's values minus the women's. Okay? All right, we do not ever pool on this because that means you have standard deviations that are the same, and the likelihood of that happening is not very likely, so we don't ever pool. Here's how conclusion might look if we have those 2 separate averages, okay? So this would be the average hours of week AP students at AHS spend on their homework, okay? So remember, when we would write our interval, we would want to show how we do that subtraction. And we have them written for 2 different means. When we do our parameters and such, we show those parameters for 2 different means, and we've defined them with those 2 separate means. Okay? All right, and so then here we have our subtraction. We did it with the Alito ones, and we're comparing that to the South Lake ones and seeing on average, or what the difference is between those 2 averages, okay? And so we're going to, in this case, I can see that these are both negative numbers, okay? And you must include the D, F, T, not Z. So our standard interval difference statement, I am 95% confident that true difference, the difference between the average for the Alito High School students' time spent on homework for AP students is between 1.1 and 0.25 hours. I probably actually should have written that 0.25 to 1.1, just because it's typical to write it least to greatest. Hours, let's see, this is kind of messing up for me. Let's see if I can't get this back to something normal. So 1.1 to 0.25 hours less than. See, the Alito High School students are spending less time, that much less time, than the average of the South Lake. And the reason is because we had those negative numbers, okay, indicating that this first mean was smaller than the second. And then when we have intervals with two items, that zero could be in there because we're talking about the difference. And if zero's in there, then there could be, then there's not evidence of a difference. So in this case, zero is not in the interval. The entire interval is below zero. So this suggests that there is evidence that there is a significant difference in the average number of hours AP students at AHS and SHS spend on homework. Okay, let's see what the conclusion might be like if the interval does include zero. Okay, so this one's about Alito residences who cross the railroad track on the way to work and the way back. And so apparently, I was thinking when I wrote this problem, I actually wrote it as if it was two separate means, but then I thought later, ooh, I probably should have done that as paired, but that's okay. We're just going to talk, we're going to say two different. So I just take everybody who gets stopped by the train, because maybe those are two different sets of people. Okay, if you get stopped by the train, yeah, that's right, it could be different people. On average, how much do you spend on the way to work? And then if you get stopped by the train on the way home, on average, how much time are you sitting there on the way home? Okay, so those could be two different sets of subjects. All right, so we are going to write this conclusion. Notice how I put the way I'm subtracting the ones going to work minus the ones coming home. And I have this interval here with the degrees of freedom stated. And I can see that my interval is going from a negative number to a positive number. Okay, so we're going to want to make sure we talk about that. So I am 90% confident that the difference between the average number of minutes a day at Alito residences who cross the railroad tracks on the way to work and home from work, so going to work and going home from work, is between 3.5 minutes shorter on the way to work. So that negative number is saying the way to work could be 3.5 minutes shorter than the way home. Up to 2.5 minutes or 2.25 minutes longer, and again, on the way to work. So in both cases, I'm talking about how on the way to work could be 3.5 minutes shorter, up to 2.25 minutes longer. So in both cases, it's about that going on the way to work, okay? And in this case, 0 is in the interval. So this suggests that there is not evidence of that significant difference. We do not have the interval completely on either side of the 0. Okay? All right. Very good. Now, let's go on to our two independent tests, our two independent means test. Okay? So we, again, pretty much do this in the calculator. I didn't even show you the t-score, doing that by hand here. Okay, I just said let's just go into the calculator. So here we just did a 2 sample t-test. Again, make sure if you have data, you would be putting it in list 1 and list 2. Otherwise, you have those summary statistics, paying attention to what context goes in first and what context goes in second, because the calculator does first data minus second data. Okay. So again, on our test conclusions, we have that same thing as before that we talked about in the previous video, where if our p-value is low, reject HO, so we have evidence of HA. Okay? And that connection to the interval would also be that 0 is not in that interval. Okay, so let me think about this real quick. if we rejected HO, okay, then we are saying there is a significant difference, okay, and so there the HA tells us there is a significant difference between those two means, okay. So 0 is not in the interval because it's going to be completely above or below 0, okay, and so there will not be that difference. One interesting thing, well, okay, never mind, no, that's fine. Okay, so there's that connection there. Now, on the flip side, if we end up failing to reject, if our p-value is greater than alpha, then we don't reject HO, so it will hold, and so we do not have evidence of a significant difference, okay? And so if that's the case, then 0 would be in that interval, okay? Because it's, could be lower, could be higher. We do not have evidence that it's completely below or above, so we don't have evidence of that significant difference. All right. And here's our final discussion about the assumptions for when we have got our two separate means. So let's take a look at that. Same as proportions, with just the difference being the independent. I'll remind you something about the independent, two different samples, okay, and then also the sample size being large enough is different than with proportions. So here we go. Make sure that when you do a random, you are stating it for both samples. You're talking about the men being randomly selected or the men being randomly assigned to the treatments. And you're talking about the women being randomly selected or the women being randomly assigned to the treatments. Independent, you're stating that both of those, the ones in sample 1 are less than 10% of the sample of the population 1, and sample 2 subjects are less than 10% of the population 2, okay? And then here, don't forget this, that those subjects, like the ones in this sample are independent of the ones in this sample, so there were no duplicates there, okay? Duplicated values. Now, I was thinking, how would that play into our little one with the train and Alito people? Because it's talking about the way to work and the way home from work. It could be the same person. It could be the same person. The point is that the numbers we have in that going to work, those are different events than the ones coming home from work. Okay, so even if we got data for the same person, each one of those, that doesn't really matter. Those are two different independent scenarios. Okay. All right, but the large enough, you have to state that both of them are greater than or equal to 30 for the approximately normal model to apply. So again, what happens if one or both of the samples are not large enough? Maybe one is, maybe one isn't, okay? Then you have these options. Go back and reread the problem to see if the population was approximately normal, and then you say, okay, it's not large enough, but no worries. It was stated that the population is approximately normal, so approximately normal model applies. Okay, or one or both of them are not large enough and it didn't say anything up in there. Then you have the individual pieces of data to be able to make your dot plot that you label very well. And you can say somewhat symmetric, unimodal, and no outliers. So the approximately normal model applies. You could have to do that for both of them. You could have to do, a dot plot for the Fish Friends data and a dot plot for the Buy Right Pets data, okay? And then you would say both of these show that both are somewhat symmetric, unimodal, and no outliers, okay? All right, so that is the end of talking about those two independent means and intervals and those conclusions that you can draw.